Hi students, this is Al Drushler, your instructor. In this objective, we are going to identify various kinds of real numbers. So, as you may know or may not know, the number system has a few distinct parts to it. We have a set of real numbers, but then we also have a set of non-real numbers. Um, this course, we're going to deal primarily now with the set of real numbers. So, the overarching set will be real numbers. So you might be thinking, what's a number that's non-real? So you might have heard, don't ever take the square root of a negative number. So that's one example of a number that's not a real number. And there is a whole other system called the imaginary numbers that deal with that. So for example, the square root of -7 would be non-real. Square root of -16 would be non-real, imaginary. Now, from the set of real numbers, we can break this set up into two subsets. First, the set of rational numbers, and I'm going to deal with this set first, and then the set of irrational numbers. Okay, so the set of rational numbers, it's real easy to remember if you know what a ratio is. A ratio is simply a value or a number that can be written as a fraction. So A over B can be written as a fraction. And of course, where B is not equal to 0. So for example, the number 2/3 is a ratio 2 to 3. Therefore, it's a rational number. The number 1.7, which you know is equivalent to 1 7/10, which you can then write as 10 times 1 is 10 plus 7, 17 tenths. So this shows that a terminating decimal like 1.7, or the proper way to say that, 1 7/10, a terminating decimal can be written as a ratio. So therefore, terminating decimals are in the set of rational numbers. Okay, another example would be your repeating decimals. Hopefully you've encountered somewhere, if you simply have 0.333333 repeating, then you've heard that this is 1/3. So as far as decimals are concerned, any terminating and any repeating decimals are considered rational numbers. Okay. Now, after rational numbers, beyond that, a subset of rational numbers are the integers. I should add up here in rational numbers that we can also have negatives as well. I did not give any examples of negatives. So -4/5 would be considered a rational number. Okay, now, all integers are rational numbers. So integers is a subset of rational numbers. So examples of integers are, and we'll start with ... -2, comma, -1, comma, 0, 1, comma, 2, comma, ... Okay, so those are your non-fractions. But 1 can be written as 1 over 1. 2 can be written as 2 over 1. All right, therefore, those are going to be rational numbers. Okay, now, a subset of integers are the set of whole numbers. Okay, your whole numbers are numbers that start at 0 and increase. So 0, 1, 2, 3, 4, so on and so forth, but no fractions. Then, a subset of whole numbers is your set of natural numbers. Those are 1, 2, 3, 4, 5, etc. So only your positive integers. Now, since 1, 2, 3, 4, 5 are integers, that means the natural numbers is a subset of integers. It's actually a subset of the whole numbers, and it's a subset of the set of integers. And then all of those are subsets of rational numbers. So everything below are rational numbers. So I have a question for you. Where would you put the square root of 16? Is that a rational number? Well, you have to, when you're posed with this question, you have to think, well, is 16 a perfect square? Yes. So the square root of 16, which is equivalent to 4, really fits into the set of natural numbers. So the square root of 16 would be in the set of natural numbers because the square root of 16 is equivalent to 4. Okay, now, we haven't got to the other set of real numbers, which is the irrational numbers. Okay, basically, the irrational numbers are going to be numbers that cannot be written as a ratio. So, are numbers that are not rational. So, I used the square root of 16 as an example of a rational number. The square root of 15, however, if you were to type that in your calculator, you would get this non-repeating decimal. Therefore, that is not a rational number. The negative square root of 3, so you can have negatives. So rational numbers can both be positive and negative. Some other ones that you've heard of, pi is a non-repeating decimal, so that would be classified as an irrational number. And something like this that usually tricks a lot of people. Negative 3.0100100001. Notice it's not repeating. So if it were repeating, it would have to be negative 3.010100101. This is not the case. So therefore, since it's not a repeating decimal, it's therefore not a rational number. Okay, so to recap, the set of real numbers is split into two subsets, the rational numbers and the irrational numbers. Rational numbers can be numbers that are written as a fraction a to b, where b is not equal to 0, basically a ratio. So anytime you can actually write a number that way, it's considered a rational number. If you cannot write a number as a ratio, then it is considered an irrational number. There are subsets of the set of rational numbers. First being the set of integers, which are the positive and negative whole numbers or natural numbers. So it also includes the opposites, the negatives. So as you can see, no fractions, no decimals in the set of integers. The whole numbers is a subset of integers because it only includes 0 and the positive integers. And then the natural numbers is a subset of whole numbers because it does not include 0. It includes only the positive integers. Okay, once again, this is Al Druschler, your instructor, and if you have any questions, please contact me as soon as possible.